Welcome to the fourth and final part of our ROADM tutorial. In this final part, we're going to look at some future directions for ROADM technology. Specifically, we will address the current debate in the industry about whether component vendors should supply entire blades. Secondly, we will look at a future application for ROADMs where they may eventually get used for mesh restoration. And we'll have a few words to say about the potential use for ROADMs in wireless backhaul.
There is currently a debate in the industry as to the future direction of ROADM's components versus blades. Today, most of the ROADM vendors, the component vendors, provide only the key component, the wavelength selective switch. A system vendor typically takes this part and integrates it with two other main components, which is an amplifier and a channel monitor, and integrates that onto a single blade, which is then placed inside an optical transport or an optical switching system. Increasingly, some of these vendors are asking the component vendor to do this level of board integration for them, and also to supply the software and the other necessary testing equipment needed to test this blade. The advantage that this provides the system vendor is that it provides much less work for them to do. On the negative side, however, it tends to move margin dollars away from the system vendor towards the component vendor. If in the future the industry moves towards this blade approach,
those vendors that supply all the different parts on this board will be at an advantage in that they will have a lower cost of production for the overall blade.
Most of today's networks in the optical realm are configured as a ring. However, as time passes, most of these networks are migrating to something called a mesh, which is shown on the right. If a portion of this mesh network fails, say the connection between nodes 1 and 7 shown in this diagram, traffic can be rerouted, for example, as shown here along the green path, and in doing so, no loss of service will be incurred. However, if ROADMs are to play a critical part in these mesh restoration scenarios, their switching speeds must switch from seconds today to the order of 100 milliseconds. The reason why this is important from a competitive standpoint is that some of Finisar's competitors are claiming that liquid crystalline silicon technology is too slow to make this switch. Finisar counters that they're working on next generation systems which are going to be much faster and will be able to meet the needs of mesh restoration in the future.
But if ROADMs are to be used for mesh restoration, much more than fast switching speeds will be required. ROADMs will eventually have to move towards being colorless, directionless, and contentionless. Let's briefly describe what each of these terms mean. Today, ROADMs are pretty much hardwired. They already know ahead of time which colors they're going to work with, the direction of transmission for each of the colors they extract, and what frequencies are going to end up on what fiber. In the future, if we want to make these ROADMs more flexible, we may need to make them colorless. That is done by marrying these ROADMs with tunable lasers. Instead of keeping all these frequencies fixed ahead of time, we might be able to reprogram what colors a ROADM works on in real time as the mesh changes. Similarly, today's ROADMs fix the direction of transmission. In the future, we may want to change the direction of transmission from north to south or east to west, depending on failures in the mesh. Lastly, today's ROADMs cannot easily deal with the situation when two identical frequencies need to reside on the same fiber. In the time domain, this is easily solved by moving the traffic to a different time slot. But the physics does not exist today to take one wavelength of light and easily shift it to a different wavelength. Tomorrow's ROADMs might need to deal with this situation in some clever way so that if a certain frequency of light is already in use and the same frequency of light needs to be dropped from another fiber onto that fiber, some new technology will be required in order to shift the wavelengths or perform some other trick to avoid this contention issue. And finally, although we have spent much time discussing how ROADMs might get more complex in the future, they may also go in the other direction as well. Smaller port count ROADMs might get installed in the wireless backhaul network. While we've typically talked about ROADMs being used to extract frequencies of light, they can also perform the opposite function by taking fibers that are lightly loaded and adding frequencies to them to make them more heavily loaded so that costs of transport can be reduced. Although wireless backhaul is a ROADM use that's probably a couple of years away, we already have begun to hear of wireless carriers considering the possibility, and this might lead to very large volumes in ROADMs, given the large amount of wireless backhaul that's being upgraded today in preparation for 4G. This concludes our tutorials on ROADMs.